Hello guys, we want to start our 14th lecture. In this lecture, I want to talk about derivatives of transform. Based on definition, so if we have fs is equal to Laplace transform of ft and n is a positive integer number 1, 2, 3 and so on, then Laplace transform of t to the power of n times ft is equal to minus 1 to the power of n, the nth derivative of Laplace transform of ft, or it's equal to minus 1 to the power of n, the nth derivative of fs. In fact, dn over this guy, dn over ds to the power of n, so it means that we have to find derivative of fs for n time. So now we use derivative of transform to solve some examples. The first example that we want to solve, so we have Laplace transform of t times e to the power of minus 10t. So we want to find Laplace transform of t times e to the power of minus 10t. Based on derivative of transform, if you just compare our example with derivative of transform, so you can see that we have Laplace transform of t to the power of n times ft. Here we have t times e to the power of minus 10t. As a result, n here is equal to 1. So n is equal to 1. And ft is equal to e to the power of minus 10t in our example. So based on definition, we have minus 1 to the power of n is 1. d over ds is the first derivative because n is equal to 1, times Laplace transform of ft is e to the power of minus 10t. So it's equal to minus d over ds. If you look at the table of Laplace transform, you can see that Laplace transform of e to the power of minus 10t is equal to 1 over s plus 10. So it means that we have to find derivative of this function. So we have minus derivative of fraction, its denominator s squared, s plus 10 to the power of 2. Derivative of numerator is 0 times denominator minus derivative of denominator. So derivative of s plus 10 is 1. So it's minus 1 over s plus 10 squared. So minus times minus is plus. As a result, we have 1 over s plus 10 s squared. So we could find Laplace transform of t times e to the power of minus 10t. Let's solve another example. In this example, we're going to find Laplace transform of t times e to the power of minus 3t times cosine 3t. In order to solve this problem, we need two properties of Laplace transform. The first one, we have to use derivative of transform. So based on derivative of transform, we have Laplace transform of t to the power of n ft is equal to minus 1 to the power of n, nth derivative of Laplace transform of ft. The second property that we have to use is first translation theorem. So you have both these two property, derivative of transform and first translation theorem in the formula sheet. Based on first translation theorem, so we have Laplace transform of e to the power of at times ft is equal to Laplace transform of ft but we have to replace s by s minus a. Now we use these two properties to solve this problem. We're going to find Laplace transform of t e to the power of minus 3t cosine 3t. You know, if you want to find Laplace transform of any function and you have t to the power of 2, t to the power of 3, and so on, so you have to use derivative of transform. If you have e to the power of at, so you have to use first translation theorem. So it applies for all the problems. So based on derivative of transform, so since we have t here, so I just compare this formula, formula with this equation. So in derivative of transform, we have Laplace transform of t to the power of n times ft. So as a result here, n is equal to 1 because we have t, and ft is equal to e to the power of minus 3t cosine 3t. So based on derivative of transform, it's equal to minus 1 to power of n is 1, d over ds, Laplace transform of ft. ft is e to the power of minus 3t cosine 3t. But now we have to find Laplace transform of e to the power of minus 3t cosine 3t. Laplace transform of e to the power of minus 3t cosine 3t is equal to, based on first translation theorem, so here a is equal to minus 3 and ft is equal to cosine 3t. So it's equal to Laplace transform of ft. ft is cosine 3t, but you have to replace s by s minus a. A is minus 3, so it's s minus minus 3 is s plus 3. So it's equal to Laplace transform of cosine 3t is equal to s over s squared plus 3 squared 9, but we have to replace s by s plus 3. So it's equal to s plus 3 over s plus 3 squared plus 9. So we could find Laplace transform of e to the power of minus 3t cosine 3t. Now let's back to our problem. So we want to find Laplace transform of t times e to the power of minus 3 cosine 3t. And we said it's equal to minus d over ds, Laplace transform of e to the power of minus 3t cosine 3t that we found it. It's s plus 3 over s plus 3 s squared plus 9. So you have to find this derivative. So we have minus here. Derivative of this function is denominator s squared. So we have s plus 3 s squared plus 9 all s squared. Derivative of numerator times denominator is s plus 3 s squared plus 9 minus derivative of denominator times numerator minus 2 times s plus 3 times s plus 3. So we could find Laplace transform of this function. In order to refresh your memory for finding derivative of fractions, so I just write the formula here. So just note it's not related to the example that we have. You know, if you have a function of ft, for example, over gt, and you want to find its derivative with respect to t, if you want to find derivative of this fraction, it's equal to gt squared. You have to square denominator, derivative of numerator, f prime t times gt, minus derivative of denominator times numerator, minus g prime t times ft. It's the formula for finding derivative of fraction. And also, if you want to find derivative of a function to power of n, it's equal to n times function to power of n minus 1 times f prime t. For example, let's assume I want to find, here we have d over dt, so I want to find d over ds of a function like s squared plus 1 to power of 3. If you want to find this derivative, so it's 3, it's n here, times f is s squared plus 1 to power of n minus 1, so it's s squared plus 1 to power of 3 minus 1 is 2, times derivative of f. Derivative of s squared plus 1 is times 2s.